Hey everyone. Today we're going to look at sine questions where sine law or cosine law could be used. So you need to decide. And then that's it for chapter 1. So we're going to be talking about, we're looking towards having a chapter 1 test at some point. How it's going to work is I'm just going to release the test as an assignment in the test folder or whatever. And we'll set a time for that. But I have to need to wait a little bit until I have more people at that part of the course. I better not try and do that right now. I don't want to mess up the recording. I was just going to go to the folder where it shows the quiz, the test, and so on. But yeah, anyways, you'll just do it just like a normal assignment, right? Just do it as an assignment and send the PDF all upright and full-size pictures on each page and all that. Nice and easy. Anyway, so let's get going. I have questions here ready to go for just cosine law, but I feel like we've done that enough lately that I'll just leave that one for you to do. Maybe at least, looking at here saying, okay, well, I've got Chris, but I don't have a cross, right? So I'm going to use cosine law. I'm going to use x as my side, so x squared, and then paired up way over on the other side, it's going to be the cosine of 1/11. In this one, there's a criss of information, if you want to call it that, and then no crisscross fully completely there. So you're just going to you're looking for angle y. And so basically you're going to start with cos of angle y and then have your information all paired up based on that, right? And so that would be the two cosine law starts at least, and then the rest gets filled in as always, right? Your side squared plus side squared minus 2 times those two sides again, boom, 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 boom. And then same deal here, squared minus 2 same sides again, right? Anyways, that's the idea of it. That's what the results are. You can just try them yourself, take it up based on what's posted there, all right? What we want to focus on now, though, is more so in situations where you don't know which one you're supposed to use. And so we'll be looking at questions like this, where it says, well, what do? Do you use sine law, cosine law, maybe Pythagorean theorem, Sapatoa? Like there's all these different tools we know to do with triangles. And to be able to pick the one that you need to use is important, right? So just focus on this page a little bit. I want to make sure you recognize that you don't really have to think of these. Okay, that stuff there in brackets is really, you don't need to memorize it, that's for sure. And we're not even really thinking of it that way, but it's what we'll see through the analysis I do on this page that they're certainly true. Okay, so sine law. It says, if you know the measure of two angles and the length of any side. So if you do this and you do this, then you can see sine law would work because you'd have a pair like that, and you'd have, a pair there. We would get B first, and then you could use you could get the other angle even actually, right? Just based on the angles in the triangle and so on. So you can see that sine law, it basically this paragraph leads to a crisscross information. So yeah, it's sine law, but did you have to know the paragraph? No, because you would just be able to look at a question and see if there's crisscross information. If there is, use sine. The other version is it says the lengths of two sides and then measure the angle that is not between. So length of two sides, and you have to measure an angle that's not between those. So either this one or the other, A or C. Again, looking at this, you've got a crisscross information, right? You've got that, and you've got a crisscross where you can figure out this one. So again, it's a sine law situation. All right. Cosine law says you know the lengths of two sides and the measure of the angle between them. So let's say we know A and C and B. Right, they're saying that you can use cosine law for that. Well, yeah, because if you look here, I suppose there's more to it than this, but you've got the pair of the side and the opposite angle, and then if you think of the full cosine law, that's the particle more to it, right? You have the b squared, and you've got your side squared plus your side squared minus your 2 times side cos of the angle. I don't have room to squeeze it in there. So cos of b. If you look at what they gave you here, you'd have the B you're looking for, the A and the C, and the A and the C again, and then the angle B, you'd know all of them. So you can tell that that paragraph describes the information that would, of course, lead to you choosing to use cosine law. What would we have done in the class, though? We would have just circled that and said, yeah, I've got an unknown and a known that are opposite each other, and I don't have another pair of those, and so I'm just going to use cosine law. And it'll just work. These paragraphs are almost more for a teacher that's trying to make a question. If I want to make a question that's cosine law, this is what I have to give you. Your job is just to solve. So it's not as important for what you're doing. If you know the lengths of all three sides, then obviously that's a situation where you can solve for angle B if you want, because you've got a cosine law that you can set up, where you have your cosine of B, and then of course you know everything else, right? All of the bits and pieces for cosine law, you'd know all of them. So that page, technically, I'm supposed to show you it and so on, but really you don't need, there's nothing new on this page really that you need, because you'll find that what we've done already just matches those wordings, which is not something we're focused on. Okay. So in example 1, are we using sine law or cosine law? And I threw in there as well, like plus, can we use the unit theorem or SOHCAHTOA, in which case you're looking at this question. Let's pause the video and so on, of course, but if you're coming back and you're saying, okay, looking at this question, there's no 90 degree, right? So there's no 90 degree, so Pythagorean theorem or SOHCAHTOA straight out as usual, like the normal versions of them aren't doable. Now let's take a look and see what we have. So I've got an angle and an opposite side pairing there, and I've got an angle and a side that I can figure out. And so sine law is possible to do, right? So you would use sine law, you would say, C over sine of 82 is going to equal another pair of sides, so 4.6 over sine 37. So that sets up the sine law ratio the right way, and then we just have to multiply by sine 82. To undo that, divide by sine 82. So we'd have C equals all that stuff. So let me grab a real calculator, but I should do it this way, right? You can see what's going on. So we can do sine of 82. So 82, do sine of it. And then I have to multiply by 4.6. This is similar to the way an iPhone works, or a phone tipped sideways, whatever. And then we need to divide by sine of 37. So divide by 37 sine. And that's equals, do the division of these. 7.569, so 7.6, I guess. Check here. Yeah, 7.6. So C equals 7.6. And you can keep going, obviously. We could get this value as well. We could work towards getting this angle as well from these ones. So those two angles would allow us to get this one. And so you have that number, and then you'd have a cosine law to get the B, or not cosine law, sorry, sine law to get the B. But just straight out here, I'm just going to do these as to solve for the one that sine law or cosine law allows you to get directly. Okay, so next one, example 2. Let's pause, think about it, come back, play along here. So again, no 90 degrees. I should just put that in for each one, but it doesn't take that long, I suppose. And so here, we've got an angle on an opposite side, and I've got a side, so I can get the opposite angle, right? So I can use sine law. So that would be, since I want angle D, I'm going to start with sine of D over 5.1, and that'll equal sine of 82 over 5.1, nope, another one, 86.2. So if I multiply by 5.1, that gets rid of it. Maybe I do all that stuff first to get a number. Sine of D equals all that stuff. So sine of 82. I'll do the other calculator this time just to show the different types. is we're using a direct calibrated logic calculator. So we do sine, this is my preference, sine of 82. It equals times 5.1. I could have used a bracket there to make sure. Times the 5.1 and then divide by 6.2. That's giving me 0.81. 0.81 dot I'll say. So 0.81 obviously keeps some decimals. And then we need to get rid of sine. So sine inverse. Go on from there. The d value, angle value is left over. So we do sine inverse second sine of that answer. The calculator's pulling in all of those decimals, giving us at 54.5 degrees. So again, that's the one that sine law was, we needed to use sine law, and that's the one that we can directly get from sine law. Moving right along, number 3, sine law or cosine law, and so on. Again here, no 90 degree. And so nope and nope to those guys. Because, and if there was, let's use it, right? It's pretty common for people to use sine law or cosine law, even if there's a 90 degree, because you've done it so much recently. But if there's a 90 degree, use sine or cos or tan or whatever directly, of course, would be a better plan. But let's take a look at what we have. We have an angle on the opposite side, and then there isn't another one. There isn't another pair of an angle on the opposite side. So we're going to use cosine law. So say there's no crisscross of information, so we're going to use cosine law. So cosine law, we're looking for z, right? So if we're looking for z, let's start with our logic paired up here to make sure we get everything put in place, right? That's going to be angle z over here to 72, right? So it's going to be cosine. Maybe I'll do the color coding there. So z squared, sine squared equals, and all this stuff, and you're going to have a cos of 72 at the end. Easy for me to say because I can move things around, right? But you might want to just know that that's going to be there and just fill your equation in bit by bit so they line up at a nice spot. You're going to have the 6.5 squared plus the 5.1 squared minus 2 times the 6.5 times the 5.1. See what I'm saying? So the luxury of being able to move this around a little. There we go. There we go. All right. But I wanted to show it that way just for emphasis, of course. So we calculate some numbers. We need to do the 6.5 squared. Is this one still awake? Falls asleep on me, then I have to use the mouse to wake it up. So 6.5 squared plus the 5.1 squared gives me 68.26. That's from all of that stuff. So I'll put it sort of in the middle here. And then we have minus 2 times 6.5 times 5.1. There we go. 66.3. And we have the cosine of 72 tagging along still. And this is the one where I showed in the original lesson, you got to make sure not to subtract that 66.3 because you don't really have 66.3. You have 66.3 times cos of 72. So it makes it smaller. So times cosine of 72 drops that number down to 20.487, right? So would have been not great if you subtracted 66, because you don't actually have 66 to subtract. You know that, right? So let's do the 68.26 number, where I could keep more decimals. Oh, actually, it gave 66. 68.26 was the exact. I don't need to do dots there. Let's get rid of the dots. I don't want to use the eraser tool because it'll be. Just hide them in there. Eraser tool would have erased more than just the dots, I'm sure. So 68.26, take away that stuff, right? So that's easy enough. Do 68.26. Take away the answer. So I'm using bunch of decimals there. 47.8. Actually, I might say 47.7 dot dot dot, because I'm still going to be doing the square root. So 77 dot dot dot. So I have the z squared equals that. And so this way we keep the root of both sides, and of course we're going to use the positive answer because it's a length of a triangle. So the root of that thing, do root right there, and answer. So 6.91 or so. 6.91 or 6.9, you know, the answer for Z. Okay, so cosine law worked out nice. And onwards and upwards here, example 4. So what can you use for this one? There's no 90 degree. If there was, we could certainly use one of those two processes, but there isn't. And so, you know, there isn't any crisscross information at all. And so this is the one we have to use cosine law, right? There's no criss or cross in this case. And so we're going to use cosine law. So we can pick whatever we want. So let's solve for Q. I'm going to solve for Q. I'm going to start with angle Q. Right, solve for Q. That means I'm going to have side Q, or the one opposite it, all the way over here. So 2.9 squared. Right, again, we've got side and opposite angle paired up. You start that way with cosine law, you'll have it in the right arrangement and give yourself a chance at getting the right answer. It's a good thing. So we've got the other sides, the 2.1 squared and the 3.5 squared minus the 2 times the 2.1 times the 3.5. Just my cos tiny bit there. So just have to solve for Q. It's a little labor intensive here, but 2.9 squared. That's that. So that's 8.41. 8.1 squared plus the 3.5 squared. I'll do together. $16.66 minus the 2 times the 2.1 times 3.5. So I'm going to do that part. 2 times 3.1 times 3.5. 14.7. Of course, that's times cos Q, right? So that's not actually a 14.7. You can subtract from 16.6 because whatever Q is would drop that down. Cosine's always between 0 and, or well, negative 1 and 1, right? So it's going to reduce it. So what we need to do is we need to solve for Q. Okay, so we're going to solve for Q. So basically we want to get Q all by itself. And so in order to get Q all by itself, we want to work towards getting the term all by itself first. So let's get rid of the 16.66. First, subtracting both sides, leaving us with the negative 14.7 cos Q. And whatever we have here, 8.41. 8.41. Take away the 16.66. Gives us negative 8.5. And so now we're going to divide. That's understood to be a multiplication there. So we're going to divide both sides. Negative 14.7. So that is for now just going to give us what cos of Q is. So 8.25. So I have the negative 8.25, so I could say, you know, divide by negative 14.7, and it'll spit out the positive answer. Or I could just divide by 14.7 and then, you know, do cosine inverse of the positive version of the answer. Either way, my preference would be just to do 8.25 divided by 14.7, knowing the answer is positive because you have two negatives being positive. But we ended up with 561. But dot, keep some decimals, take the root of both, not the root, correction, right? We want to get rid of cos. Ahead of myself there, so we need to go cos inverse. Gets rid of cos, so we need to do cos inverse in that thing. Second, cos, the answer gives you 55.859. 859, so maybe 55.9 if we're going to one decimal place. Okay, so just be aware, right, in questions that aren't specifically from cosine or sine law, obviously you've got to figure out what type of method or what type of formula is needed. So just notice in this question sheet, it's not nearly as much work as it looks, because in the first question, you're just asking you to say whether sine law or cosine law would be used to figure out the angle that they're asking for, so, or the information, I should say, they're asking for, so side B and angle X. So just show, justify why, do a crisscross analysis kind of thing, and I asked you to set up the equation as well. So you're going to have a sine law set up, but I'm not asking you to solve it out. Obviously, that's the more important part of the process, right? Setting it up, so that's why I want some more practice with that. Same thing here, it's just saying for angle A, so in each one, for angle A, sine law or cosine law, and just set up show why how you know, and set up the equation. Not actually asking you to solve it out. In part 3, solve for angle B and angle C and side C, using sine or cosine law as appropriate. And then number 4, it's more of a little bit of a work your way through problem solving kind of question, right? Multiple step, but just focus on what you can figure out step by step. Huge hint, maybe I'm just looking at it. I haven't worked through the question fully myself yet. You know, obviously you can figure out that angle. If that is a number, that might help, and so on and so on. Okay, so that might be a first step, but work your way through it. Okay, so if you have any questions, please post a new, start a new thread in the whatever you call it, the discussion section there. I should, hopefully this doesn't do anything weird here. Add new tab to the right. That should be fine. I'm just going to show it quick here. On your class page here, you've got this post questions. And so you just go into the post questions here and you start a new thread. Okay, I showed that in the last video as well. Yeah. All right, that's it for now. There we go. Until next time.